Welcome back, CodeYun Fam. Have you been keeping up your grind? Remember, practice deliberately, focus, work hard. Make no excuses to get to your goal. Let's get to it. In the last video, we went over JavaScript objects. We looked over what JavaScript objects are. We also went over how we can create, read, and update them. We left off with some sweet dot notation and bracket notation work on an object we created using the old school way of using a new keyword and object constructor. In this video of our JavaScript Objects mini-series, we'll look into object literals and we'll set the stage to learning about JavaScript Object Notation, or JSON. What's up, new kid? So I need you to produce some magical code that holds some information around tacos. It also has to hold information about my favorite tacos. Oh yeah, and it'll have some functionality that will get a bunch of different taco types. Ooh! And maybe it can identify the current tacos that are on sale for my favorite day, Taco Tuesdays. Oh yeah, and new kid, I need this ASAP. Now I know you're super eager to get to coding, and your motivated self is telling you, let's get this done now. But let's take a step back. Let's slow down and break down the term object literal in fancy computer science terminology. An object is a list of 0 or more pairs of property names and associated values enclosed in curly braces. Gross. A literal is a notation for representing fixed value in source code. Disgusting. Now, I don't know about you, but when I hear fancy words like this, my brain yells to me, WTF. So, simply, an object literal, 99% of the time, has a variable that points to curly braces with a bunch of properties and values. Important to note, you can quickly make it anywhere in your code, and you can set initial properties. In our example, the variable nacho object is pointing /assign to curly braces that have a bunch of properties that describe a nacho for us. Super yummy. I don't know about you, but this is a much better way to learn than the dense definitions out of, say, a Comp Sci 101 class. So you're now back at your desk, you're caffeinated with your earphones in, and ready to grind. Let's take your new assignment one requirement at a time. The first requirement is to figure out how you're going to store some data around tacos. Take a second to pause and think about how you would like to start coding. Remember, it's all about just getting some code down and letting it evolve to a masterpiece. So how would you tackle this? For me, I will start by setting a variable to point to an object literal. This will allow me some flexibility for my solution, as I've already created an object and we've learned through dot notation or bracket notation that we can update our object as we please. The second requirement is to hold information about your CTO's favorite tacos. Well, this requirement shouldn't be too bad. So how would you approach it? I'll give you a hint. Remember that we learned objects can be programmatically updated as well. My solution, although simple, would be to just hold my CTO's favorite taco in a variable. In this case, the variable is called CTOFav, and the value is asada. For fun, I also want to create a variable that holds my favorite taco, in this case my fave, which is a quesarito, or some would call it an abomination. Let's remember the big picture. We are creating an object literal that will hold some data for us and can solve our solution quickly. So far, we can see that if we choose to use this solution, then we could programmatically update our object literal with our CTO's favorite taco, and maybe add in our own or even a user's. Moving on. The third requirement is around having various functionality for getting different taco types and taco sales information for Taco Tuesdays. This is a bit more complex, but when you see action words in the requirement, you should think, maybe a function would be my solution. So, how would you approach this? Take another second to think. I've created a taco types function that takes in a type of taco and analyze if it exists or not. We use a bunch of conditionals to check if the type of taco that's being passed into our function as an argument hits either an asada or quesarito value. If not, it will send back a statement saying, lo siento, we don't have said taco. Next, I've created a variable that holds the taco special for Taco Tuesday in a variable called taco sale. In this case, the special for Taco Tuesday is the quesarito. Now, here's where it all comes together. We could use dot notation and bracket notation to add the information we created into our initial object literal, and I'll leave that as an exercise for you to perform. But I'm going to just create another object literal called taco literal final with the information I created. The property Tuesday special is being set to the value taco sale. My taco is my fave, CTO taco, CTO fave, and get taco is being set to the value of the function that we created. Does this make sense so far? If not, do not pass go. Rewind to make sure that you take this in piece by piece and you understand everything. You can do it. Now, how can we test our work? Does our work make sense? What would you do? The most basic way for us to test our work is to console out the different properties within our object literal. Testing in depth is beyond the scope of this lecture. I'm sure we all love unit integration and end-to-end testing with that glorious 100% test coverage. But anyways, let's console log our function, the Tuesday special and our CTO's taco. Is this what you've expected? If so, congrats. Remember that in this scenario, we needed to create some type of way to hold information about tacos and have access to specific functionalities. One topic always comes up when I review code for junior engineers. Let's look back at our object literal. Get taco is currently doing what? If we say console logging taco literal final dot get taco, as I have highlighted here, what would be the result? This trips up a lot of junior engineers. What do you think it is? Is this what you expected? As you can see, it returns back a function definition. You need to actually invoke the function, or just execute it with parentheses, and our executed function expects an argument of a type of taco. Otherwise, the parameter will default to the value undefined. To hone the concepts we just learned, let's try another example. I've created a variable taco literal 2 that points to an object literal. I've written 5 console log statements below. Pause the video. What do you think are the expected outputs of each one of these console logs? The first console statement is using dot notation to first access our object literal, in this case taco literal 2, then access the property taco menu, whose value is another object literal, and then accessing the property menu 1 and returning back menu 1's value, which is asada. Great. The second console log is utilizing bracket notation to access the property 3. Would you have been able to do this with dot notation? The third console log is accessing property 4 within our object literal. Were you able to understand why it returns our function definition? The next two are tricky, and I see confusion around these two all the time. Our fourth console log is trying to use bracket notation to also invoke / execute our function. However, remember in our last video, bracket notation is trying to resolve whatever is inside the brackets. In this case, For is trying to be resolved first as a function. But this is a bit tricky. Numeric literals, examples are like 1, 2, 3, 4, etc., cannot be functions, and a function identifier cannot start with a numeric literal. This is kind of a JavaScript 101 type of thing when it comes to function identifiers. The last console statement is the proper way to execute to resolve the identifier for, which will convert to a string, then will invoke the function as you see in the last console statement. Thank you for watching this video, and this concludes part 2 in our series. In the next video, we will cover JSON and why it's so important for modern day web architecture / networking. I'm proud of you for getting through this difficult lesson, and remember, think of the big picture when executing your solutions. Get something on paper and let your code evolve to a masterpiece. If you enjoyed the video, please like and subscribe to support.